Adding complex numbers. Our problem is the square root of 3 minus the square root of 6 times I plus the square root of 27 plus the square root of 54 times I. So let's put our real parts together. We have the square root of 3 plus the square root of 27. Now let's put our imaginary parts together. We have negative the square root of 6 plus the square root of 54 times I. Okay, we can simplify the square root of 27. Let's rewrite 27 in terms of its prime numbers so we can identify the perfect squares, so we'll know what we can pull out from under the radical. So let's write 27, make a factor tree. 3 goes into 27 9 times. 3 goes into 9 3 times. So 27 is 3 times 3 times 3, right? So we can write the square root of 27 as the square root of 3 times 3, which is 3 squared, times 3. Okay, since the square root of 3 squared is 3, I can pull that 3 outside of the radical. So I have 3 times the square root of 3. So the square root of 27 equals 3 times the square root of 3. So let me write the square root of 27 as 3 times the square root of 3. Let's go to the imaginary part. So negative the square root of 6 cannot be simplified. We have the negative square root of 6, but the square root of 54 can. So again, let's write 54 in terms of its prime factors. Let's make a factor tree. We have 54. 2, a prime number, goes into 54 27 times. 3, a prime number, goes into 27 9 times. 3 goes into 9 3 times. So the square root of 54 can be written as the square root of 2 times 3 times 3 times 3, which is 3 squared. I have a perfect square, so I can pull that out of from under the radical. And then I have 2 times 3 inside, which is 6. So the square root of 54 equals 3 times the square root of 6. So now let me add my radicals. I have the square root of 3 plus 3 times the square root of 3 is 4 times the square root of 3. And then I have, for the imaginary part, I have negative square root of 6 plus 3 times the square root of 6 is 2 times the square root of 6, I.